So since we're going to be using the CSpresso project, or part of it, the bubble sort low fidelity prototype, and its user study as a sample model throughout the semester, I thought maybe I should go through just a bit. So this is the website, or my website. This is the project that we've been focusing a lot on, that hopefully I can wrap up my PhD on. Again, it's a virtual reality and an augmented reality educational technology for beginner computer science, whether it's middle school or high school or maybe even college. But this is the book format. This is like a phone right here on a tripod. This is the AR version. So you see some trackers here that the AR app on Unity can recognize, and it displays 3D graphics above this thing here and some 2D graphics down here. But you're supposed to read on the left-hand side. You read the textbook, and then you do the activity to reinforce whatever you learned. It's like doing problems at the end of the section in a math book, but the problems are in augmented reality. So this all kind of started from here, this binary math. We started with binary counting or binary math, and we had this idea that we want the user to move around. So what's so unique about virtual reality is that you can actually like move through the graphics. You can actually stand up and keep the computer screen basically on your head, on your eyes, and walk through the game, walk through the experience. And so we wanted to see if making abstract concepts more physical, more imbued in the physical realm of 3D spatial and the 4D of time helps people to understand and appreciate and have fun with learning computer science. And here's the stations that they're moving through. This is the phases of learning. So this is experiential learning, but it's very similar to constructivism. And you're introduced to something, you learn about it, you practice it, and you apply it, and you demonstrate. And so you could loop this whole thing and put it into a learning loop. And this is what our teaching method that we went with. The players spawned in the middle, and they move around these stations. You can kind of see it here. Here's the number station, the color station, finishing the task with the output station. So you're given a task. Give me 3 red spheres. So you have to interact with the number station for 3. To get the correct output, you got to move over to color station and interact with it to turn the levers into red. And levers on off for binary representation. And there's another station, color station. So let me just jump over here. This is the final version. So low fidelity, meaning don't put any effort into graphics, put all your effort into the user experience, the interaction design. And then once that's tested and you have a lot of feedback, you refine the experience, the UX, you refine the interaction, and then you put a lot of effort in the presentation, which this is where we got to. But here's the number station. This is the color. This is the shape station over here. So cubes and spheres and cones and what have you. It's a little hidden, but at least you can kind of see it. This is the big idea. We're in this like world, this like fun spaceship island world, and you have to fix stuff. And so this is us going through our first, just like writing stuff out and like prototyping with just objects in a room and trying to figure stuff out. We're in the gaming lab here, mixer lab. Here's Adam, he's now a researcher, and here's Jess. And here they are trying to figure out a fun way to make the number station with nothing but just a whiteboard and sticky notes. This is the point. You're supposed to do stuff super fast and iterate until you find something that works. And here we are just on a table, just moving stuff up and down and like writing out what the interface would look like and how it would work as you're working with it. And here's sending and receiving. Here's the station where you get tasks and you give your final output back to see if you solved the task correctly. So get task and send it. We start with the mission statement, and it came like this, the task station. And here's the color station. We thought we were going to do dials to have a more of like a wide range, not just up and down or on and off, but that became too cumbersome for a new person. Here's a really bad sketch, but thinking about how the ergonomics, the height and what feels good with a station or a kiosk compared to an average human height. And here's some sketches for what the number station before we even start thinking about it in 3D. And using a lot of references like CSpresso machines and what have you. And this was a first iteration. You can see this to this. There's been a difference in it. Here it is, 2. I want to do powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2, which is actually what the binary is representing, but it's too much information. It's too complicated, so we reduced it. Oh, here's what all the stations were. Here's all the stations in low fidelity. Get your task here. Go to number station. Go to the shape station, and then the color station. So I know that you would say like 3 red spheres, so you think color would be next after number, then shape, but shape's actually an easier station. There's less handles, less options than color, so we swapped shape with color. And then you go to the color station, and then when you're really happy, the output shows the number, the color, and the shape. And if you really like it compared to what your task is, you pull the lever here, you get some stuff, and you bring it over to the task station and send it up to fix the station or whatever the task might be. This right here is the tutorial station. I had to end up teaching them what's a lever, how do you pull it, how do you understand on and off, which I'm going to talk about later on in the class. I actually found it easier to develop the first level and then to think about what do you need to teach somebody to play the level, to use the experience. So actually you build level 1 and then you go back and you build a tutorial based on what you need to train the user on your software, your interaction design, the terminology you're using, what's expected of the user. So you actually kind of do the tutorial at the end, or what I found is most useful, helpful. And here's the final rendering. Here's some storyboards, interaction storyboard, how the user might interact with the station. This is them being like trained. Where am I? What do I care? How do I know to go up to a station? And here's a storyboard of like a tutorial how this character Eggy shows you around, moves you, and teaches you how to pull levers. And we figured out there needs to be a personified, personalized narrator kind of showing you how to use the experience. Here we thought maybe they would be carrying around a type of iPad system, but then we kind of dropped that because it's kind of hard to train them that there's something else in the world. You have this thing you're holding on to, and we skipped it and had this little character. And here we're talking about which part of the controller is the gamepad. For you, it's mouse and keyboard, but we're saying what parts execute on which type of interactions. Then here's what the hand pulling on a lever would look like when you're using the controller. Here we start to modeling the stuff. Here's what the environment sketches might look like, what our finished environment. Here's our user testing. We went to a middle school summer camp in the gymnasium, and we set up, we trained the users on what to expect when we put them in, and then we put them in on Quest, our standalone VR, separated out in the gym, and they did the experience. And we tested them before and after, and this was one of the papers. In either case, if you're interested in the paper, it's this learning science paper here. This is the paper we ended up writing, part of my PhD requirements, and it's explaining the study, why we did it, what's the point of it, what we hope to achieve, and the data. What did we test? How did we interview them? What type of results came out of it? And ultimately a discussion of those results. What does it mean? What's our opinion of it? And a conclusion, a wrap up on the paper, and references of all the papers that we referenced before that. And down the road, I'll be talking about the design doc, and I showed you the dev blog earlier. Here's the code base to it. In either case, that was Bubble Sort, and then we ended up doing an AR version of it. So this is working on the phone, looking at this book. And we have a different type of interface here. It's a little card game with AR. And we went through a lot of testing how this might work. Again, same like storyboards and wireframes and a lot of drawings and quick iterations on paper to how this textbook might look, down to how like we have to think about like how does tracking work with images and what makes for a good tracker, and how do we make these black and white images that the AR core framework on Unity with Android can pick up these images really well, and so on down, and until we built the AR. So we also have walkthrough videos. If you're interested in the low fidelity prototype for binary math, it's here. The high fidelity walkthroughs here, and the AR app is here. And so this is like a portfolio site meant to like explain all these kind of large projects, and that's why we're having you do something similar. You're creating documents, you're going through the full process, and you're going to create a walkthrough video and an interactive demo at the end. And the last one I wanted to show you was, this is the actual sample I'm going to use, this bubble sort. So it's a low fidelity prototype. We just focused on the user experience, the interaction design. What are we teaching? The learning design of it. And didn't worry about the graphics. And we got it working until we were able to do user study and see if it was a good learning method, which it ultimately was. And this concludes my PhD. It actually did have those who were able to walk through the list as opposed to standing did actually learn better. So anyway, that is kind of just the backlog of the whole point and all of our research that went into the bubble sort trainer here, that you'll be just using the WebGL to test and to see as a sample, and to I'll explain the code of this, and we're not going to do AR, we're not going to do VR. All right. So that's it. At least that's good grounding for what this sample project bubble sort's going to be, that we're going to spend the sample will be for the rest of the semester.